Hey guys, good morning. Welcome to another session. Today we'll be going to advanced um, blockchain mathematics, advanced arithmetic and algebra applications. But we won't be doing so much calculations today. We'll be understanding some concepts. So we are more knowledgeable on these before we go full dive into calculations. I'm going to drop the link to this slide. Yeah, Simon, good morning.
Good morning.
Yeah, so I just dropped it on the call, in the groups, and also on the call, and I've pinned it. Okay, cool. I'm sure you can see the screen now. So I'll just proceed, ending when the rest joins the call. All right, so let's start. Sorry about that. So, in the previous classes, we've spoken a lot about basic um, arithmetic, basic algebra, and we spoke about variables, equations, exponents. Is there anyone who wants to give a quick recap of what variables, equations, and exponents are? Okay, so like I said initially, variables are more like placeholders for values. They are unknown values that are used in an equation, and they are there to take the space that is allotted to a particular, or that will be allotted to a particular variable, and it's a particular value, sorry. So variables are just placeholders. They are there for a temporary moment, just to ascertain and solve for the value that that variable is representing. And variables can take the form of X, Y, Z, A, B, C, alphabets. They are represented with alphabets to distinguish between the coefficients, the numbers, sorry, to distinguish between the numbers in an equation. When we talk about the equation is any form of expression that has an equal hand, the left hand side and the right hand side, opposite each other but joined together by the equality sign. So the equation is there to is with an expression is an expression that checks the equality of both the left hand side or the right hand side. When we talk about exponent is talking about degrees, talking about power of the power of a particular um, equation, power of a particular number. So if you say x squared or if you say y squared, these are exponents. These are exponents. They are raising them. Excuse me. They are raising 2 to the power of something. So that is what exponents are. What is the relevance to blockchain? These concepts are crucial for smart contracts and cryptography. They form the backbone of secure and reliable blockchain applications. The reward example is to show you complex smart contracts and their use of maths. Okay. So they form the backbone of secure and reliable blockchain applications. And like I said yesterday, you use this arithmetics and algebra to solve for transaction cost, to solve for transaction values, data value, variable costs in your smart contract, to help you with the logic, with defining your logic, with implementing your logic, to help you with balances, to help you with analysis, and a whole lot of things on the blockchain is being done leveraging mathematics, leveraging this basic algebra and arithmetic on the blockchain. And so this is the significance and the relevance of the mathematics in the blockchain space. Moving on to the next. What's going on? Okay. Solving algebraic equations. We have started with the simple linear equations. We have started with the simple basic equations where you have one variable to solve for that particular variable. We have not gone into complex variables yet where you have two or more variables to solve for at the same time. But we are on the right track. And you have x plus 5 equals 10. In blockchain, these are used in smart contract input validations. And that is why every time we solve for it and you find x, I tell you to explain why x is the answer, or to validate the answer is truly what we got for x. And then you need to replace x with that answer and make sure the left hand side cancels the right hand side perfectly. And so that is why it is needed for input validation, to be sure that your answer is correct, to be sure that you don't need to trust um, the answer, it will always be correct. It will always be valid. So all these things need to be put in place. All these what do I call it? Methods or background checks rather needs to be put in place to ensure that the answer it gets is actually the right answer it is meant to get, and it is going to pass through the process you expect it to pass through. And yesterday I told you of board math. You have to make sure it doesn't go through addition or subtraction first before going to multiplication. You have to verify and put checks in place. Is someone trying to speak? You have to verify and put checks in place that it passes through the right process. That is, it does the multiplication first, and if there's a division, it does the division first before going to the multiplication. The next going to the addition, if there's an addition, before going to subtraction. If not, the logic is going to be very, very faulty. Okay. Um. So for verifying that a transaction amount does not exceed a user's balance, these linear equations is very, very paramount. So you can use substitution or elimination to find solutions. We'll get to that soon. So for quadratic equations, mastering solving equations like this, factoring and the quadratic formula are essential. In smart contracts, this can model complex conditions such as calculating gas fees based on transaction size and computational complexity. Example, gas fee is equal A times size raised to power 2 plus B times size plus C. A times size raised to power 2 can be defined as the gas fee, while B times size can be seen as the um, transaction size, while computational complexity can be seen as C. And then when you sum all these together, you get the total gas fee it will take to complete a transaction. So for smart contract inequalities, when we talk about inequalities, we mean things that are not equal, right? Things that are not the same on the both hand. So when the when the left hand is not equal to the right hand side, that is when you deal with inequalities. And also note that for inequality is always checking between sibling um, constants, between sibling items. So it is always checking between the left and the right hand side. That is, the two numbers that are next to each other on the mathematical line or the expression or the equation. So if you are checking that A is equal B, you cannot check that A, something like B plus A is equal A, B plus C is equal D. You cannot check that B plus A is equal D. It has to be the sibling number just immediately after the equation sign or the operator that you have to check in between. So inequalities are crucial for defining conditions and ranges in smart contracts. They determine execution paths based on variable values, ensuring contract behave as expected. A token distribution scenario, an inequality can ensure that only accounts with a balance greater than a certain threshold are eligible to receive additional tokens. So here is the smart contract code that checks to make sure that it is only addresses or accounts that have a certain account balance or above that are eligible to receive some airdrops or something. So you can use this logic to check for that in your smart contract, only accounts that have a particular NFT that are eligible or have participated in a particular tax that will be eligible to receive the airdrop when you're trying, or the token distribution, if it's airdrop purpose or whatever purpose you are doing a token distribution. So here we have a solidity code contract called token distributor. It takes a mapping of address to in 256 called balances, and it has a function distribute tokens. Distribute tokens takes an array of address and the array of address called recipient, and a uint 256 called amount. And then it checks starting from the first position in the array, checking across the recipient length, that is the total number of recipients in this address. So the total number of indexes that are currently in this array, starting from, you know how an array calculates from zero index, right? It calculates from the zero index to the final index. And then it checks for the length, and then it increments. And it says that for each of the indexes starting from zero, it should require the balance of the recipients and check that the balance is greater than 10. You know, this hand is the greater than sign, the greater than hand, right? Don't be confused. So your right hand, if you kind of a bit curve your right hand, it will give you this sign. And if you kind of curve your left hand, it will give you the other side. So it requires that the balances of each recipient should be greater than 10. If not, it will return insufficient balance to receive your tokens. But if the balance is greater than 10, it will come to this next line where it will update the balance of the recipient with the amount that was just added to the balance. Do we understand this smart contract logic here? Good morning, Marietta. Thank you. Guys, do we understand smart contract? Nobody is talking. Nobody is responding on the group chat. I should come again. What part? All right, I'm going to explain it again. Token distributor function. Okay. All right. So I'm sure you all are now conversant with the smart contract based on the classes you've been having, the 10 o'clock classes or afternoon classes you've been having. And some of you have deployed your smart contracts, right? Now, sorry about that. I always say that the smart contract is as smart as the person that wrote the logic, the engineer that wrote the logic. This smart contract is a contract that checks that an address has a certain balance in it before it goes ahead to distribute tokens to that particular address. Now there is a specific amount that should be distributed to these addresses. Starting from here, we have a mapping of address to unit 256 that is called balances. So this mapping shows us the balance of every address that is going to be in this scheme. So it will show us the balance of all the addresses that are going to be in this scheme. Now, so if you pass in an address, what is going to happen is that the balance is going to be returned for that address. And the balance is a unit 256. So this mapping, you can look at it like a type of object, normal object in JavaScript that takes a key value pair, right? You have a key and then you have a value. So this address is actually the key, while this unit2 verses should be seen as the value. So in this mapping, this is what you impute into it. This is what the output will be. You are the one to define the kind of output you want. If you want the output to be the balance, you know that the balances are of a uint data type, integer data type, right? So you're going to put this. If you want maybe the names of the persons, when you pass in this address, names are saved with data type of strings, right? When you pass in the address, you'll be expecting a string instead of a uint. And public, you call it whatever name you want to call it, names or name register. So when you pass in an address, what will come out at the end of the day will be the name of that address, the owner of the address, or the name of the holder of that particular address. Right now in this mapping, what we are trying to gain from this mapping is if we pass in an address, we want to see the balance that that address has. So we can check if the balance is greater than 10 to decide if this address is qualified for our airdrop or not. Okay, so hope this line is clear now. Now we have a function called distribute tokens. Thank you, Simon. We have a function called distribute tokens. This distribute tokens takes in a parameter of an address array in memory called recipient. Now, this recipient is an array of all the addresses of the recipients participating or that applied for this token distribution. Okay. The next parameter distribute tokens hold is an amount. This is the amount that you want to distribute to all these recipients in this list, in the address list, in the recipients array. So you want this specific amount to be distributed to all the recipients in this function. So now we can go with a for loop. that loops through this list of addresses, that is the recipient's list, and checks for each list at each index, checks for each checks in each address at each index to be sure that the address holds a balance greater than 10 or lesser than 10. And so you create your for loop and you say for I equals 0, if I is lesser than recipient dot length, it should increment. So what this means is, I'm sure you all know your programming languages and you all know what happens in a for loop. What this means is that you are starting this loop from the very first index, which is index 0. You want I to take the value in index 0 and check that I is lesser than recipient's length. What is the length here? If you have 10 addresses here, the length of this array will be 10 because it counts how many addresses are here. Now, why are we saying we want I to be lesser than recipient length? Because we have 10 addresses here, we check the, you know that it's for an array, the index starts from 0. So to get 10 indexes and you start with 0, it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It won't be 10 because you're starting from index 0. It will only be 10 if the array is starting from index 1, right? But it's actually starting from 0. And 0 to 9 is actually 10 places. So if you have 10 items, they will actually be in 10 places. That is 0 to 9. They will not, it will not take up the 10th position, which will be the 11th item. So it's not going to take up the 10th index, which will be the 11th item in the array. So we check that I is lesser than recipient.length. If you check recipient.length, it will give you 10. And our last item in the index is 9, right? And I is taking up the indexes. So if the 10th item in the array is 9, 9 is actually lesser than 10. And that is what we want. Because if it gets to 10, that means the recipient length will be 11. And we want to check that their balance is greater than 10. Right? We want to check the balance should be greater than 10. But if it gets to 10, we can't make that check because the logic will get faulty because the recipient length will now be 11 instead of 10. So you check, you go through this for loop, you make your condition. I plus plus means after it goes through the first index, it should increment and move to the next index until it completes all the checks for all the addresses in the array. The next thing is that you require the balance of the recipient. Now, this balances is this mapping, right? And this balances is taking an address to return the balance to you. So you want to check for the balance of all these recipients and you pass in for the balances. You want to check the balance of this. Which address first do you want to check? If there is a particular address, you can just pass that address directly. But because this is an array of addresses, you need to pass the addresses at each index. So you have the balances, and then you pass this recipient at position I. So recipient at position I should be greater than 10, right? And so you check this first I, this the for loop, the first loop it does is that it checks that I is equal 0. So at this point, balances checks the recipient at position I. If I is 0, this will be recipient at position 0. It checks the balance of this recipient at position 0. So this address at position 0. What is the balance of that address? If the balance of that address is greater than 10, this logic passes. This it passes the requirement check and moves to the next thing. What is the next thing? The next thing would be that the balance of that particular of this recipient at position 0 is going to be incremented. That means this amount you wanted to add to the recipient balance, if the recipient balance is greater than 10, will get added. Then you have to write the logic that shows that it is actually added and not replacing. Now in your smart contract, if you want to add to an existing value, you cannot just use that value plus this. Okay, you have to check what that value is first, then add to it. And that is why you see the plus and equal sign. The plus and equal sign means if this is 10, I want it to add this amount to it. And I want this balance to be equal to the new amount. So it's as if you're doing you're writing two codes here. The first code is showing that you want balances to add, you want amount to be added to balance first. Then the next thing is you want the previous balance to now be equal to this new balance. But then this is going to update it. It's going to do the addition and it's going to update this balance to be the new balance and not the old balance in just one line using the plus and equal sign at the same time. So after it does this for recipient at position 0, it will go back to the loop because you did I plus plus. It is meant to go back to the loop and put I plus plus. I plus plus means I plus 1. I plus 1 will now be 1. It will now check for I in position 1. What is the balance of recipient at position 1? Is it greater than 10 or is it lesser than 10? It will do this, come back. I is now equal to what is the balance of recipient 2? Is it greater? It will keep on repeating this loop, this loop, this loop until this condition is fully met, where it has gotten to 9, to the ninth index. When it wants to come to the 10th index, this is going to fail because you want I to be lesser than 10 and not equal to 10. So it will check that I maybe is at position 10. But when it comes to this next line that I should be lesser than 10, it will not be lesser than 10 any longer if I is in 10. So this condition here is going to end, is going to fail, and then you'll be out of this loop and proceed with the other implementations you have on ground. Now, this is a basic token distributor smart contract that checks all the addresses in an array to be sure that these addresses are qualified for the airdrop. How? By checking if the address already has a previous balance that exceeds 10, and if not, they will be disqualified from the airdrop. I just hope that was clear. In this example, the required statement uses an inequality, balances greater than 10, to check if an account balance is greater than 10 before distributing tokens. This prevents accounts with low balances from receiving the tokens. Let me check for questions. Where did we define the require function? Here. We require that balances should be greater than 10. So if you can see it here, this is where the require function was defined. Are we good, Banjo? Yes. You define it yourself. You define it yourself, but require is a keyword in Solidity, okay? So if you use require, it is going to check for an equality thing. It's going to check for true or false. Just like in programming languages, you have the for loop in almost all programming languages. The require here is also in Solidity that checks if this statement is going to be true or false. If the statement is true, it will continue the logic. If the statement is false, it will break out of the logic. Okay, so modular arithmetic and exponentiation. This will be very, very um, complex at this time for you. Quickly check. So I'm not going to touch this until we do some solving under these um, advanced algebra part before we come into modular arithmetic and modular exponentiation. But let me just read it to you. Modular arithmetic involves performing arithmetic operation within a defined range using the modulo operator, that is percentile. For instance, a plus b mod m ensures the result is always within 0 to m minus 1. This is fundamental in blockchain for creating hash functions and ensuring data integrity within fixed size blocks. So this is why we are not going into this. Not now, not yet. Modular exponentiation calculates base raised to power exponent modulus. It's a critical operation in public key cryptography like RSA and Feldman, used extensively in blockchain for secure key exchange and digital signature. So this is just good for head knowledge, but this is too advanced. This is going into ZK and cryptography. So we wouldn't be touching this yet until we have a good understanding of this. And I don't want to confuse us with our blockchain class. So we'll basically be doing lots of other mathematical stuff and checking our logic in the smart contracts. All right. So questions, or are we good? If you have a question, please ask. Yeah, thank you, Banjo. All right, if we don't have any more questions, I think this will be the end of today's class. Tomorrow, and subsequent classes, we'll be doing much more of calculations and much more in-depth smart contracts, logic implementation, and it will not be me handling the class. it will be us or you guys explaining and giving the implementation of the smart contract and why we should use this method over the other method. So prepare yourselves for that. Thank you guys and see you in the next class.